Good morning and welcome to our lesson, section 2.2 on power functions with modeling. Power functions are an important family of functions in their own right and are important building blocks for other functions as well. Let's take a look first at what the definition of a power function is. Power function looks like this: f of x equals k times x to the a. A is considered the power of the function. K is considered the constant of variation. A and K must be non-zero constants. Again, non-zero constants in order for this to qualify as a power function. They may be negative, A and K may be negative, they may be positive, they may be fractions. They just must be non-zero and they must be constants. They may not be variables. Let's look at a few commonly known power functions and talk about them in the terms that we refer to power functions in. The first being the circumference of a circle. C equals 2 pi r. Now, we normally don't write the first power, r to the first power, but it is in fact there. So a in this case is 1, so this function has a power of 1, and k in this case is 2 pi. So the circumference of a circle function is a power function. The power is 1, and the constant of variation is 2 pi. We would refer to this function, the circumference of a circle, as varying directly with its radius. C, the circumference, varies directly with its radius. Another important power function that we know well is the area of a circle. Area equals pi r squared. As we can see, the power of the function is a, and the constant of variation k of this function is pi. We would say that the area of a circle varies in direct proportion to the square of the radius. Area is directly proportional to the square of the radius. Another important power function that we are probably familiar with is the force of gravity function. F equals k over d squared, which we could write or rewrite as k times d to the negative 2. In this particular case, we have a power function, and the power is negative 2 because the value of a is negative 2. K in this particular function is not defined. We will just redefine it as k. Another is Boyle's law. Volume of a gas is indirectly proportional to the pressure placed on that gas. This can be rewritten as k times p to the negative 1. So the a value here is negative 1, and k is just left as k. Force of gravity we would describe as acting upon an object and that it is inversely proportional to the square of the distance from the object. Inversely proportional because the power function is in the denominator. Likewise, for Boyle's law, it states that the volume of an enclosed gas varies inversely with the pressure applied. These both represent inverse relationships because, again, the power is a negative in the denominator. Another important function for us to focus on is the monomial function. F of x equals k times x to the n. Similar to the power function, but a difference is k is a constant. That is exactly the same as a power function, but n must be a positive integer. Remember that in a power function, the a value could be anything non-zero. That is the primary difference between a monomial function and a power function. I hope you have enjoyed this overview. I hope it has been clear. If you have any questions,